grading today because, um, but overall for the exams, come on, I completely forgot to make the form. Sorry about that. I'll do that basically once I stop doing the recording. It's been a hectic couple of days, if you haven't noticed, right? So, regardless, I'll get the form to you. Again, as I said during the exam, the auto grader can only detect what is definitely right. And if you don't use the exact term in the exact same way, it probably marked you wrong, and that's okay. So just let me know. You're probably right. Right? So like, one of the answers was ancestor, but I didn't code it in to recognize grandparent. Or maybe I didn't, or maybe it was case sensitive for grandparent. I'm not sure. But the point being is that it's quite possible that you got marked wrong. And of course, it's a completely right answer, right? Overall, what did people think of the exam?
It wasn't too bad.
Seemed much easier than the first.
Yeah, definitely easier than the first one.
Well, maybe it's just because you've gotten more skilled. Have you thought about that?
That is quite optimistic. I guess I'll go with that one.
Yeah, go with that one. You all need all the self-confidence you can get. Programming's hard, so definitely you should definitely try to, internalize the message that you are a genuine tough guy or gal, as it is. There's a stronger term that I wanted to use, but I do try my best not to curse in class. So, let's go ahead and talk about the latest assignment, or the one that will be due the soonest. I'll also go ahead and post the other two assignments. So with the sorting assignment and all the following assignments, you are free to use whatever programming language you like. I believe I've mentioned that before, but it bears mentioning again. You are freed from the confines of Java. In fact, once you get to algorithms, really, it doesn't really matter what programming language you use, probably. I think Dr. Hughes uses Python and MATLAB. So let's go ahead and take a look at this, right? So sorting algorithms, I didn't give it a due date. Let's go ahead and just slap one on there. Say sometime next week. That sounds great, actually. Let's just slap that due date on there. So sorting algorithms. This one is actually one of the easier assignments to do. Okay, because you're going to hear something that basically you probably never heard from a professor before. You should totally go online and copy paste code from a website to do this assignment. Probably haven't heard that from a professor before. Now, of course, I would like you to now, of course, because we are working in an academic setting, definitely, even though I said, yes, you can grab stuff from online, you still need to cite it, right? Because giving credit where credit is due is a big thing in academia. So just simply make a comment saying, this is the URL I got it from. That's all, right? Just never represent somebody else's work as your own. And this one, I deliberately do want you to go out. A good source for this assignment, by the way, is Rosetta Code. It's like Rosetta Stone, but Rosetta Code, which is basically a website, which basically says, here's a task, here's how you do it in a bunch of different, here's how you do it in a bunch of different programming languages. So let's go ahead and look at Quicksort. Right, so I'm going to go and look that up. Sorting algorithms, Quicksort. Here's the pseudocode from Wikipedia, it says. And then here's the list of all programming languages that it's been implemented in, or that they have an implementation for it. For instance, here's an assembly language implementation of it. Okay. Here is another assembly language. Boring, right? But let's go ahead and look for Java. It has both an imperative way and a functional way. Ooh, look at that. That looks really nice. Like really, really nice. So here, so there's a couple different ways to do it. It's the translation of the Python code, they say. So another way, or you could go and look at, say, or if you're working in Python, we can go and look and say, hey, here's the Python code. You can look at that. Now, one of my favorite kind of things over here is what we call a queen or a quine. think it's quine or queen. Well, it's really interesting kind of programming concept here. Completely off topic, but it's a self-reproducing automata or self-copying program or self-copying computer program. It is, the task is basically to write a program that prints out, that outputs its own source code. All right. So you got to be able to write a program that outputs its source code. Now that doesn't necessarily sound that hard, but let's take a look at the C version. Oh, that looks like vomit, right? But what it is that basically basically the output of this code would be this. The include standard standard io.h in Java, and we can see basically how powerful different languages are by doing it like this. Here's one in Java. They're very interesting if you try to figure out how they are digested. Here's another one in Python. Python's a bit more, is quite a bit more syntactically quick like that. So there's a number of them. Anyway, quines are interesting, but here's a great source for you to be able to find that. Now, why am I telling you to grab stuff for this assignment? Well, let's take a look at the assignment details. Right, that probably would help elucidate. So here, I want you to implement insertion sort, quick sort, and one other sorting algorithm from the list below. So be it either shell sort, which is one of those, it's in your textbook. I don't really go over it because the runtime for it is weird. We don't actually know what the runtime is because there's different variables. We know like different variables can yield like O of n squared or n root n, or sorry, n root 2. Sorry, n to the root 2 power, but we just don't know how fast. I think it's n to the root 2. But, or is it square root of n? No, it's not square root of n. Anyway, but point being is that shell sort has these different, that basically based on the way you do it, it can have different runtimes, and we don't know what the optimal runtime for it is. It's still an unsolved problem. Merge sort, great for linked list. Heap sort, or if you want extra credit, you can do tim sort, which is the default way that most programming languages do sorting these days, which is a combination of insertion sort and merge sort. So what we need to do now, so here's why I tell you you can do this. You can copy paste from somewhere else. I need you to modify the sorting algorithms to keep track of the number of comparisons performed and the number of exchanges performed and the total runtime of the algorithm. Okay, so the idea here is that basically that you are going to collect samples, right? So your output might look like, your samples might look like this, right? Let's go ahead and increase this to like, oh, come on, I want to increase the size of the table. Okay, your outputs might look like this. So here we've got insertion sort. And what we're going to say is we'd like to do it for, we'd like insertion sort. So num items, num comparisons, or average comparisons, average exchanges. And yes, I will make this much easier to read. All right, so basically, let's say you run on 64 items. Then then basically what you'll want to do is once you have insertion sort ready, you'll want to create like an array of 64 items and then see how many comparisons that takes, which would be somewhere around 64 squared, right? And notice I say notice I say average comparisons. That's because I want you to do multiple runs and take the average of it. The average exchanges, again, similar, some data, and then some at the average runtime. Then you'll want to compare another sample. I suggest going up by powers of 2s. So double of 64 is 128. And do basically the same thing over here. And then 1 and 1 after that is 256, right? And you should be able to, and so on and so forth, and you should be able to graph that. And then you want to do that for every algorithm. The point being is that you want to see that exponential curve, okay? So either output them into a file, or you might just copy and paste and dump it into an Excel file, and then present your data. So the grading is basically 20 points for implementing insertion sort, 30 points for implementing quick sort, 20 points for implementing the third algorithm, 15 points for data collecting the data, and 15 points for making sure the data is presented. Okay. Again, more details are in here. So what is the best way to basically keep track of your data points in Java? Okay. Let's go ahead and I'll open up IntelliJ real quick just to give you the 2 ways I think are best. So, and I'll go ahead and while that's loading up, let's go and grab insertion sort from Rosetta. Insertion sort, by the way, is my favorite sorting algorithm because it is simple and it does one thing that other sorting algorithms can't do, which is that it can sort things online, meaning that you can give it data while it's sorting and it won't care. It won't have to start over the process. Other algorithms would have to start over if you basically say, oh, and I need you to sort one more thing. So couple things. So let's go ahead and file new. Let's just do it in here. Sorting. Okay, sorting experiment. So there's 2 ways to go about doing this, right? So here we have our insertion sort algorithm, right? Whatever. Okay, one way to do this is to basically have a static int num comparisons, static int num exchanges, right? To have 2 static variables to keep track of stuff. And anytime where basically we compare things. So over here we do a comparison. So I do num comparisons plus plus. And then over here we do an exchange. So let's see. Yep. So this would exchange things, num exchanges plus plus, and then num exchanges plus plus over here. Right. So anytime we swap 2 things, that's an exchange. Anytime we see if something's out of order, that's a comparison. So that's one way and then basically you reset it each time you run it, right? You save your values and then you reset it each time you run it. Another way, which is a bit more, how to say, object oriented and possibly much more better, is to create a private class, a private static class, so it can exist by itself, private static class data, which contains basically contains 2 fields. Int comparisons is equal to 0, int exchanges equals to 0. And in what you would do is that basically in each, you would return a data item when you're doing your running. And so what we do over here is we would just simply say data is equal to new data. And then over here, when we're going to do a comparison, we would just simply do data got comparisons plus plus, and we fill it in all the other places. And then when we're done with the algorithm, we would just simply return the data item to be collected by a list or something. Make sense? So those are the two ways I would say that are the easiest way to make your changes to the program to gather data.